This is the solution video for the advanced puzzle Tweezers, published June the 14th of 2024. And it features a square containing two semicircles. The diameter of the smaller semicircle is extended to the origin, and also a line through the origin is tangent to that smaller semicircle. And we're asked to find the coordinates of this red tangency point, given that this is the origin and here you have 1 0 and here you have 0 1. And it's quite a lengthy calculation, but I'm gonna go through it step by step. First, the points. What I'm gonna do is I'm gonna draw this line segment. And from the larger semicircle, we know that here we have a right angle. And suppose I name this length A, then the diameter we say has length B. Then from the similarity of this right triangle and this right triangle, we know that this line segment must have length square root of AB. Okay. Now we're going to apply Pythagoras in this right triangle, and that implies that a squared plus AB equals 1. Yeah, the side length is 1. And now we're gonna calculate this, the length of this tangent. Let's say it has length K. What we know is if we take the power of the origin with respect to this circle, let's say if you complete the smaller semicircle, you get a circle. You can take the power of the origin, and then you know, because this is a tangent line, that that power is, on the one hand, it's k squared. On the other hand, if I go along this line, you know that the power is a times a plus b. So that gives an equation in k, namely that k squared must be equal to a times a plus b. But now we can use the equation we just found, and it's exactly the same as a squared plus ab. So we know that this is 1, and we have found that this length is exactly 1. So if you would draw a circular arc, you would find that indeed it is exactly on that circular arc. Okay, let's remove it again. But we haven't yet used these two equal angles, but we're gonna do that just now. Well, let's draw some other segments. If I go from here to here and from here to here, we use the fact that this is a semicircle. We know that again here we have a right angle. And well, let's say this is angle alpha, the green angle, and we know that alpha is also over there. That's a given. So alpha is over here. So the remainder here, this small angle, is 90 minus 2 alpha. On the other hand, if I look at this angle, let's name it beta, then I can use the alternative segment theorem to show that this angle over here between the tangent line and that line is also beta. That's the alternative segment theorem. And we can use that to, if you look in this triangle from the origin to the point F to the tangency point, and you add up all those angles, 90 minus 2 alpha, beta, 90 plus beta, and you equate that to 180, you will find that alpha exactly equals beta. So let's put that over here. Alpha equals beta. But this implies that this line segment, if you see that here alpha makes an angle with this line segment, and here it is the angle also alpha, so you know that this line segment is parallel to this line segment, and so this is a horizontal line, and this is from the 90-degree angle is a vertical line. But that implies that I can extend that vertical line to here. Yeah, this is a straight line. So if I now add the required coordinates, this is x, the coordinate of the tangent, the x coordinates of the tangency point, and this is a rectangle, so y is over here, the y coordinates that we are looking for. Those are the two variables we are looking for. Well, obviously here we have 1 minus x, and using the this semicircle, we know again from similarity, here's a right angle, here's a left angle, that this height must have length of the square root of x times 1 minus x. That we know. So that's this height. Okay, we're almost there. First I write down what we have found, that this length k is 1, and so that's using Pythagoras, x squared plus y squared, this y is also over here, x squared plus y squared is 1. It's on the circle, the unit circle. That's one equation. The other equation comes from comparing this right triangle with the similar triangle over here, and that implies that y divided by 1, so that's the tangent, basically the tangent of alpha, y divided by 1, must be equal to what we have found, square root x, square root of x 1 minus x divided by x. Yeah, so this divided by this is this divided by this. So here we have found two equations with two variables x and y. Well, I leave that to the reader to solve, but it is not that hard. It solves to x equals 1 over phi, the golden ratio, and y equals 1 over the square root. 1 over the square root of the golden ratio. So there we have the coordinates and the answer to the question. The coordinates of this tangency point, the x coordinate is 1 over phi, the y coordinate is 1 over the square root of phi.